Okay, so from the video you must have seen a matrix is basically a list of numbers put in a square bracket like that. So if I ask you, what is the size of this matrix? So you say how many rows, which is 3, and then you count how many columns, which is also 3. So you say 3 cross 3 like that. Similarly, this one is 3 cross 3. Now this guy can also be considered a matrix. What is the size of this? 1 by 1, 1 row and 1 column. And this will be called a scalar. It's also a matrix, but it's really a scalar. If it's 1 by 1, yeah. So we'll basically try and do the mathematics on the matrices. Now, if you do classes like data sciences, game theory, if you're doing mathematics, then these topics are important. Also, if you do advanced economics, you'll have to do this again. All right, the first thing we'll see is how to do A plus B in Excel. Now, can somebody tell me how do you do in general A plus B? Right, you just add the elements to each other. So now can you tell me how can we do this here? It's brute force, so you do equals. Say it again. So we just do this plus that one. Brute force. You just do like this, and then you scroll to the right 3, and you scroll to the down 3. And if you check, this plus this is that. So this is an example of A plus B. To make things more presentable, you can just select each matrix and give it a light color just to show that these are the matrices, like each one of them. All right, similarly, you can do A minus B. That's simple. Now just make a note, A times B is different than A x B, okay? Just make a note. A times B, if you see something like this, it's element multiplication, and this will be matrix multiplication. Okay, so if the question is just do elements multiplication, just like A star B, then all you have to do is multiply individual elements, which will be similar. All you do is this multiplied with this, enter, drag to the right, and down 3. This is element multiplication. This is not matrix multiplication. Okay, we'll see matrix multiplication in a bit, but this is element multiplication of a matrix. All right, similarly, if I tell you do a scalar times a matrix, tell me how do you do that? So we want to do matrix C times, let's do A. So all I want to do is take this number and multiply to all of them here. Any ideas? How do we do this? Very good. What you have to do is you have to fix the scalar and just multiply it to the rest. How do you fix something? You press Fn and F4 on your keyboard times this guy, and then all you have to do is move to the right 3 and down 3. This will be scalar multiplied to a matrix. This is addition, this is element multiplication, and this is scalar multiplied to a matrix. Any questions so far? It's straightforward. Now let's see actual multiplication. Now matrix multiplication now. So here's a question. The size of this matrix is 3 by 3. And what is the size of this? 3 rows and so 3 by 2. So here's a question. Can you multiply any two matrices? You cannot multiply any two matrices or matrix. You cannot multiply all matrix. Write down the requirement is yeah, very good. So the column of the first matrix needs to be equal to the number of rows of the other matrix. Only then you can multiply them. And then this guy will be called M1 multiplied with M2. This is matrix multiplication now. So look at this. The number of columns for this guy is 3, and the number of rows for this guy is 3. So that is a requirement for them to be multiplied. And the final result will be the remaining two elements, which is the number of rows of this guy and number of. So the size of the multiplication will be 3x 2. And make a note, M1 cross M2 is not the same as M2 cross M1. So you can multiply M1 cross M2, but you may not be allowed to multiply M2 cross M1 at all in this case itself. Right? This is 3 by 2 and this is 3 by 3. So you cannot multiply them. All right, now this is how you multiply matrices. So you select first the size of the new matrix, which is 3 by 2. Then you press equals. And very important, write down the function is called M ULT, M multiply, like that. M multiply. M stands for matrix multiplication. And open a bracket. And then select the first matrix. You cannot select M2 first because M2 is not the first one here. M1 is the first one. And comma M2. Close the bracket. And make a note, you do not press enter. You press Control, Shift, and enter together. So Control, Shift, and enter together to get the answer. So look at that. If I do Control, Shift, enter, you get the whole matrix as an answer. So this is M1 cross M2. When you practice, you can do more. The next one will be called transpose of a matrix. Right, what do you understand by transpose of a matrix? Was it there in the video, transpose? So any guesses? What is a transpose of a matrix? Transpose of a matrix is it converts the rows into columns. So in this matrix here, how many rows do you have? And how many columns? 4. So if you transpose this, it should be the opposite of that. So this guy should have 1 column and 4 rows at the end of it. So what is the size of this matrix here? Yeah, 1 by 4, right? If you transpose it, the new size should be 4 by 1, the opposite of it. So what you should do is select the size first, and do equals transpose and open a bracket and select the original matrix. You press Control Shift and so look at that. 1358 here becomes 1358 over there. Does that make sense? Well, let's do one more. What is the size of this matrix? 2 by 2. What should be the size of its transpose? 2 by 2, same, yeah? Now remember, where the columns and the rows are the same, it's called a square matrix. And most of the time you'll deal with square matrix. So if you do the transpose of this, what should you expect? 2, 5 in the first column and 1, 3 in the second column. Let's see. So first select the size, equals transpose, and select the matrix. And press Control Shift and so look at that. The rows become columns. Very good. Let's move on. The next important bit will be called two things: determinant of a matrix and the inverse of a matrix. Okay, now write down the inverse of a matrix will only happen for a square matrix. So we'll only do inverse for a square matrix. And the inverse of a matrix exists only if the determinant is non-zero. So if the determinant of a matrix is 0, you conclude that the inverse is not possible. So if the question is find the inverse of a matrix, step 1 should be to find the determinant to check if it exists or no. And the determinant is a number, it's not a matrix. So it's a scalar, it's not a matrix. And this again will be used in game theory and data sciences and all of that when you do the application. So let's see how to find it. It's really complicated if you do it just by hand, okay? This is an easy example of a 3 by 3, but if it's a 4 by 4 or a 5 by 5, it takes like hours to do it. So this is way better. So you do equals M, DETER, M determinant. So M determ. Open a bracket and select your entire matrix. Close the bracket. And for this guy, you can just press enter. It should give you the answer. So look at that. The determinant is negative 290. It means it's not zero. We are okay. Now, very important, the inverse of a matrix. This one has a lot of applications, which we'll see one or two. But the inverse of a matrix, make a note, is the same size as the actual matrix. So what is the size of this matrix? 3 by 3. So the answer should also be 3 by 3. We're doing the easy ones, but when you're doing real life problems, like in chemistry or something, I've seen 1,000 by 1,000 matrices when you analyze the behavior of a chemical reaction and stuff like that. So this can go crazy in engineering. All right, so let's see, you select the size. And the formula is equals M inverse. This one here, M inverse. And all you have to do is select your matrix. Close the bracket. Now, do I press enter here or control shift enter? Control shift enter. Whenever you're selecting a big chunk, you will have to do control shift and enter. So this is the inverse of this. And similarly, this is the inverse of this. They both are inverses of each other. So if you try to find the inverse of this guy, you'll end up with this guy again. Now there's a way to check if you've done your work correctly. So write down how you check if your work is correct. So what you do is you try and multiply these two matrices. So multiply A with A inverse. What should be the size of the resultant matrix? This is 3 by 3. The other is also 3 by 3. 3 by 3, right? Because everything is 3, so it doesn't matter. So what you do is you do your selection of 3 by 3. Equals, we are multiplying. So what is the formula? What is the function called? Yeah, what is it? M-M-U-L-T, M-mult. Put a bracket, select the first guy, comma, select the other one. Close the bracket. Now, if I press Control Shift Enter, what do you think will happen? What should be the answer here? What is something multiplied with its inverse? What is the inverse of 3, you think? What is the inverse of 3? 1 over 3, right? So if you multiply them, what do you get? 1. So in this one, what do you think will happen? We should get 1 everywhere. Any other guesses? Let's see. So if I do Control Shift Enter, only 1 on the diagonals, right? Only 1 on the diagonal. Everywhere else you get 0 because they cancel each other out. And very important, this matrix that you got is called the identity matrix. And the diagonals have to be this way down, okay? They cannot be this way. They have to be this way down. Very important, this is called the identity matrix. Now here's the question. If you do A inverse multiplied with A, will you also get identity? If you do 1 over 3 times 3, do you also get 1? So this is A times A inverse, right? A times A inverse. If you do A inverse times A, will you also get identity? Any guesses? Yes. Okay, so make a note for this guy, it works both ways. A times A inverse is also identity, and A inverse times A is also identity. But that's not true in general for a matrix. A times B is not the same as B times A. So you can check when you do this to do M 2 times, or you can't do it, but in general, you can make up a problem and check. You'll see that it's not the same. Okay, now let's see an application of this. What is the application of this? Why are we learning this? So this will be used in solving system of equations. Right, so you must have seen simultaneous equations in 2 dimensions, but this is simultaneous equations in 3 dimensions. It means if 3 planes are touching in space, what is their intersection point? And this could again be 1000 by 1000. There could be 1000 variables or a very huge matrix. So how do we solve this in Excel? We make this into a matrix and solve it. So let's see how. This is the method. Write down, you find the matrix A, and multiply it with the variable matrix X. So you find the matrix A. Just write down, then we'll do it. So A is the number matrix, X will be the variable matrix, and B will be the matrix on the other side. And to find the variables, what you will have to do is find the inverse of A and multiply it with the matrix on the other side. We'll do it so it will be makes more sense. So tell me, what is the variable matrix here? What are the variables here? What are the unknowns here? So the variable matrix is X, Y, and Z, right? This is your variable matrix. You can make it more presentable. You can color it, make it colorful, and maybe borders. This is your variable matrix. So now what we want to do is we want to find matrix A now. Right, how do you find matrix A? What you do is you take the variables of each of the, you take the numbers in front of each of the variables and make a matrix. So the first row will be 5, 4, and 9. The second matrix will be 2, 4. Very good. Is it making sense? We're taking the coefficients of the variables and making a matrix. And the third one will be 2, 5, 4. This will be your matrix A. And what will be your matrix B? So 95, 32 and 61. Makes sense? And the equation is AX equals B. So this multiplied with that, if you do, you should get that. Because you multiply rows with columns. So it's 5 times X plus 4 times Y plus 9 times Z equals 95. That's what the first equation is. Right, that's how you multiply the matrix. So now to find X, what we do is we take the inverse of A and times it with, let's put a space, times it with B. So we find the inverse of A and multiply it on the other side. So let's find the inverse of A. So what should be the size of the inverse now? Also 3 by 3, right? Because the original is 3 by 3. And you do M inverse. All you have to do is, first you need to check if the determinant, okay? Every problem will not have a solution, but this one has, I know. But in general, if a question shows up, find the determinant first. And Control Shift and enter. So this guy is the inverse. You can check if you've done your work correctly by multiplying and making it identity. Now, so the new X, so X, Y, and Z will be the multiplication of this guy with the blue guy. Inverse of A multiplied with B. Make a note, it's not the same as B multiplied with the inverse of A. It should be inverse of A multiplied with B. What is the size of this? Yeah, 3 by 3. What is the size of this guy? 3 by 1, right? So what should be the size of your answer? Can you multiply these two? That's the question. Which one? Yeah, yeah. Think AX equals B. So X should be A inverse times B. Is right. Something is wrong here. Should not be. Right, so if we transpose this, then it should work. But is that right? Yeah. But that's not the normal method. Let me think what's going on. Most times columns.
It just looked wrong because inverse A is below.
So this is 3 by 3, this is 3 by 1. So 3 is equal to 3. Yeah. So the answer is 3 by, yeah, right? Because if we put them next to each other, it's 3 by 3 and 3 by 1. 3's are equal. Make sense? Yeah, so that's why maybe you should write the inverse of A on the top, yeah, not to confuse you. So now let's see. 3 by 1 is that equals M alt. What should you select first? The inverse of A first, comma, B, close, Control Shift and enter. So the value of X is 20.625. The value of Y is that, and the value of Z is that. If you just check 5 times this plus 4 times this plus 9 times that, that should equal, we can check it, this times that plus this times that plus this times. If I press enter, we should get, then you're doing your work correctly. 25. Right. Similarly, you can check for the others. So this is the main application of this, which you will have to do in a word problem of economics. So let's see the word problem. Something like this, which you can try and do when you practice. There are 3 word problems which you'll have to do for practice. You can do all of this first and then move on to word problems. I'll help you if you can't do it. Any questions before we close this? So up till here on the first quiz, yeah. I may not put all the questions, but up till here I can select, but study everything. Any questions here? Is this clear what the confusion was? Okay, cool. Put the practice on